We found the strongest evidence to date of possible biological activity on an exoplanet. DMS stands for dimethyl sulfide. This is a very important molecule because here on Earth, DMS is produced uniquely by life, microorganisms in the ocean like algae, phytoplankton. And theoretical studies had predicted for the last 2 decades that molecules like DMS would be very robust biomarkers on exoplanetary systems, including planets with hydrogen-rich atmospheres like Haitian worlds. K2-18b is an exoplanet orbiting a red dwarf star about 124 light years away. It has a mass of about 8.6 Earth masses and a radius of about 2.6 Earth radii, and it orbits in the habitable zone of its host star, which means if you put an Earth-like planet at its location, we would think of it as habitable. So the technique we used to determine the atmospheric composition of the planet is known as transit spectroscopy. What is happening is that you look at the planet as it transits in front of the host star. So the atmosphere of the planet, some of the starlight goes through the atmosphere of the planet before reaching the telescope. And the atmosphere, the molecules in the atmosphere absorb some of that starlight. So by looking at a differential measurement when the planet is in front of the star or when it isn't, you can extract how much absorption is happening in the planet's atmosphere. So 2 years ago in 2023, we reported a very tentative inference of DMS on this planet with a different set of observations with a different instrument in the 1 to 5 micron range. But the evidence was very tentative, so we looked this time at the planet again in a different wavelength range. And what we are finding is significantly stronger evidence at a 3 sigma level for the presence of either DMS or DMDS or both. Now, DMDS, like DMS, is also a strong and unique biomarker here on Earth and had also been predicted to be a biomarker on planets with hydrogen-rich atmospheres. And that is what is new, is that there is a possibility of one or both of these molecules to be present in the atmosphere at a credible level of significance. So while this is great and evidence to keep looking, this is not enough to qualify it as a robust scientific discovery. For that, we need to reach the level of 5 sigma. What does that mean? At 5 sigma, you're talking about the chance of a fluke being about a part in a million. So we are pretty confident about our results at the significance that we are finding at this 3 sigma significance, and that's partly because we have done enormous number of robustness checks. We have done it with multiple pipelines, and within the same data reduction pipeline, we have tried various assumptions on how we can reduce the data, and no matter how we did it, the signal always persisted. And to us, that's a great measure of our confidence in the detection at this level. But we should remain open-minded and get more observations so we can repeat this signal. That's the hallmark of science, the repeatability and increase in robustness till we are really, really satisfied. We are not there yet. So the question you may have is, have we found life on another planet? And this answer is simply no, not yet, right? So we have to, as I always say, we have to be very careful in 2 directions. The detection we have made is at a level where it is very interesting. It's a landmark result, but it is not good enough to call it robust just yet. This is a big signal we are looking at. This is of very high importance. We need more observations to get it to that 5 sigma level where we would be much more confident, number one. The second aspect of that is that when we do detect, and while we are making these observations, we also have to remind ourselves that while DMS has been predicted to be a robust biomarker, there is always a possibility that we may not have accounted for some physics that we don't know so far, or some chemical process that we don't know of. So we want to remain open and do as many theoretical calculations and lab-based studies to say if there is any process which can get DMS in such an atmosphere at the levels that we are seeing. This is one of the most profound moments for me personally, as well as an astronomer, because for the first time in the history of our species, we may actually be seeing signs of life elsewhere. On the other hand, this could also be a signal of a new chemical process that is not produced by life, and even that is a monumental breakthrough, because however you put it, we are seeing new chemical processes on a planet that could be habitable. And we have shown this in theoretical studies that was possible. So this is, in my view, a transformational moment, not just for planetary science, not just for astronomy, but for finding our place in the universe as a species.